So that's a lead into when they're talking about all that encapsulation stuff. Leads into, and this is something you may not want to do. And I don't know if it's part of our LOs or not. Are the networking models part of that? I think there is something about networking.
Yes, it is.
So maybe you do have to do, maybe you should do this. But let me make this smaller so we can get it all up there at once.
I mean, is that like abstraction or something?
So this is, this is another example of abstraction. These networking models, and there's two of them, and this is only one of them. This is the smallest
Internet.
one. And it's the only one I go through in CS principles. But it explains what happens from at the top, the application, what happens, and then they break it into another layer of transport. And the purpose of this, of doing it this way, is it's easier to learn pieces. An auto mechanic isn't going to learn, okay, fix this car or build this car. They're going to learn piece by piece how to fix the different pieces of a car that might be broken. And so the same thing is here. Break it into pieces. It's easier to learn each piece than it is to learn the whole thing at once. So after they understand it a little bit, then I break it into pieces and make them learn what each piece does.
And those are not in order.
Again, I'm not going to go through that, but
Those are not in order. Those
they
just-
are in order,
Yeah.
from top to bottom.
Transport comes before internet?
Yes.
Or it's higher to
Yeah.
It's a higher application, or it's a higher level in the layers.
Layers of responsibility. right?
So briefly, it goes like this. At the application layer, I open my web browser, so I'm using HTTP. And so that's the application part of this. I generate the data there. I request a web page. The transport layer, because it's a web page, I'm going to use TCP instead of UTP. Well, what's the difference? TCP is very reliable. They double check things. So if I'm sending you a packet, or not a packet, but you know those thousands of packets. I send you 100 of them. You're going to reply to me and say, "Hey, I got those 100. Send me the next 200." Then I'll send the next 200. And until you tell me you got the first 100, I'm not sending you the rest of them. And so that's how it's reliable. And if I don't hear from you in a set amount of time, I'll send you those first 100 again, and again, and again, and again, until you replied and said, "Hey, I got them." Now I think it's 16 times. I'll try 16 times. After that, too bad, so sad. So when you get the server unreachable error, you've attempted probably 16 times to get to it. So that's TCP. UDP, on the other hand, is like in the movie. Here's 5,000. Just go. And we'll put it back together when they get it. The thing about that is they all go in line, like little soldiers down the parade route, one after another. They all go the same way using UDP. And so they come in the same order. How many people have watched the movie and you had a little bump in the movie where something was missing? Well, one of the packets got lost on the way. So then the next question is, well, who uses UDP, who uses TCP? And so then I ask them, if you're playing a game, do you want it to be fast or do you want it to be reliable? Which is more important in that game? Well, we want it to be fast. So they're using UDP in the game. What about videos and songs? You want those to be coming right at you. Streaming videos, streaming music is using UDP. Also there they add a number. It's called a port number. It's really irrelevant what it's called. But it identifies that I'm using HTTP at the top, or I'm using FTP, or I'm using POP, whatever it is. And then at the internet layer, We had the internet address. That's what the routers use, is the internet address. And then at the network layer, we had the MAC address. So they said, well, why do I need two addresses? Well, one is for local delivery, and one is for long-range delivery. So if you're sending a package to your grandmother in Nashville, you put her name, her street address, and her town and zip code. The post office here doesn't care about your grandmother's name or her address. They just care about the zip code. That's like the internet address. Once it gets there, then they worry about the other part. And so that's a good analogy to use. And then I make them reflect on that as well. And then I have, and maybe you want to show this before, it's just a brief, the different layers and the protocols at each layer. So you could show that before also, or after, as a review. And just so you can see the notes that I put together. Those are just kind of the whole thing in text form, a few pictures added in of things that I go through.
Jim, I got a question.
Yeah.
When I was kind of looking and trying to prepare a little bit of an internet unit, it said there was 5 layers. There's a link layer. What's that about?
There's either 4 layers or there's 7 layers.
Oh, okay.
Depending on which model you're in.
So 5 is off.
The TCP/IP layer is really how we look at the internet. If we're looking at networking, then we break it into smaller pieces and have 7 layers.
Okay.
And one of them is the data link layer.
Okay.
And the data link layer is part of the network access layer of the TCP.
Okay. That makes sense.
So if we don't have a marker.
Did you talk at all about the subway or something?
Not in this class. I don't talk about the OSI model, but in my other classes I do.
You mentioned net neutrality. Did y'all discuss that? Or?
We have, when this is all done, then we have a discussion where kids can bring up whatever they want to talk about the internet. And so that's where we bring up innovations, net neutrality,